Hello and welcome to my Two Quantifiers podcast. And today we're going to talk about AI, its risks and mitigations. And we have again a special guest. His name is Michail, I'm sorry. And he is an expert to an extent that you can be in AI. He has done research in AI and read a lot of research as well. But, instead of me saying all these things, I think it's better if I just pass it on to him. Welcome, Michail. How are you?
I'm good. Hello, Ivan. Pleasure to be here. I've been doing AI safety for the past at least 3 years and studying it maybe a couple of years prior to that too. And I'd be happy to talk about the risks from AI because it seems like one of the most consequential technologies of our time.
Okay. So first, let's maybe give some background because even I am not fully in the loop of what has been happening. So what would you say has so you all obviously witnessed the birth of modern AI in like late 2022 when GPT-3 was released by OpenAI and all people were amazed at it, how much it could do. But what has actually changed in the last few years since that release?
Well, many things changed since the release of ChatGPT. I think if we were to give our listeners a bit of background, I would maybe start even earlier and say that somewhere in early 2010s, the deep learning revolution happened, and there was this AlexNet moment, right? Where researchers from, if I remember correctly, Toronto University, one of which was Ilya Sutskever, now very famous, published a paper where they showed that they can do image classification much better than any previously known methods by using a couple of GPUs and a very deep convolutional neural network. And since then, deep learning has been steadily on the rise. 2017 saw the invention of the transformer architecture for language models. And apparently, the story goes that OpenAI, which did already exist at the time, the same Ilya Sutskever woke up and in the morning read the paper on transformers, came to the office of OpenAI and told to the researchers, guys, drop whatever you're doing. This is it. This is the next thing. And then they started working on transformers. And so I think maybe even the same, I don't know, a year or two later or something, GPT-2 was born. And that was only an aha moment for people kind of more in the loop. GPT-3 is 2020, right? GPT-3 was when I personally, for the first time, got kind of the shivers from the speed of progress. It seemed very surreal that this thing was able to write these articles. Now, obviously, we would recognize them as kind of more sloppy, but also at the time, there was no post-training loops. And so the articles, in a sense, were more alive than what AI can write today. In some senses, obviously, AI did become much better, and even though post-training kind of does lead to mode collapse and these sorts of things, you still see much better quality, especially technical writing, but still GPT-3 was a very big moment that human-like writing is even possible, and that was 2020. Then ChatGPT is 2022, and that was obviously where the world learned about this and where OpenAI became a really big thing from like a research lab that was concerned with AI safety. And since then, the biggest development, GPT-4 got released. That was before reinforcement learning post-training and everything, and that was probably 23. And that model had insane scores on a bunch of benchmarks, like it could do grad school level exams sometimes, if I remember correctly. And so that was a moment where we saw not only that the thing can talk, but that it can be competent in certain things, right? Then we saw O1, which OpenAI advertised as Strawberry early on. And that was the first reasoning models. And in a sense, it was kind of foreshadowed that reinforcement learning will at some point come back into AI. And it is only surprising that it took so long. But in the end, people did manage to make reinforcement learning, which I will refer to as RL, working. And so the models could reason before they answer. And the reasoning process was guided by the specific kind of training where you train the AIs not on every token of what they're saying, but on the outcome. So, for example, you can give them a mathematical problem and only grade the AI on whether it solved the problem correctly. Yeah. And so that was the next big thing. Then you saw the open models. In the AI development in general, the kind of the thresholds that are passed by the technology are labeled by people who talk about this often as X moments. So like GPT-4 moment, ChatGPT moment. Then there was the DeepSeek moment when the open source models came out that also can reason. And we realized that China has the sovereign AI industry, which maybe trains a little bit on Western models, but still exists. And we also saw a bunch of how the sausage is made, because DeepSeek released a very detailed paper on how exactly they did the RL. And so this led to kind of blooming of research on post-training on how to do RL. And now we have all these kind of open source tooling or semi-open source tooling. You have, for example, Tinker, which allows you to train things fairly easily. Yeah. And then the other moment that happened actually very recently, I would argue, is the moment of the Mythos model from Anthropic. So this is maybe a month old news or 2 months old news, I don't remember. But essentially Anthropic released this model that was able to autonomously search for cybersecurity vulnerabilities in software at scale. And the model they claimed was so powerful that they should not be releasing it to the public, and instead they released it to a group of trusted partners, or trusted partners specifically of the US, who used the model to patch the vulnerabilities before they become a bigger thing. And so the project was dubbed Project Glasswing. And within this project, Anthropic essentially tried to ensure that who they think are the good guys get the AI first, and then they can use it for defensive purposes before some sort of offensive cybersecurity chaos ensues. Then for 3 days only, they released very heavily safeguarded version of Mythos that they called Fable to the public. And then US government suddenly claimed that no, they cannot be releasing these models to the public because it's too dangerous, because someone claimed that there is a jailbreak that allows the publicly released model to be used for cyber offensive capabilities. And so the Anthropic had to pull back. So I guess one of the more recent developments in AI that is heralded by these news is that the governments are getting more and more involved with directly, governing the development of AI. To the level of, we will block a specific release of a frontier model. This is not a thing that has happened before, and this is not a thing that was thought of as conceivable by many of the people in the fields. So this is quite a surprising development, I would say.
Yeah. I also read about this. However, as I understand, and correct me if I'm wrong here, we don't really know what made this Mythos model so much better than the previous release, right? It's not disclosed by Anthropic whether they used some sort of new learning technique algorithm to do it. You said that GPT-4, which was, I suppose the last big release where we know what made it better, you said it was because they introduced reinforcement learning into...
Sorry, that's not the case. GPT-4 was just like another step of a much bigger model. I don't know. I guess they did use better post-training techniques, but reinforcement learning was not introduced with GPT-4. That was introduced with the model that was called O1 later, I think probably next year.
I see. And what specifically, in a few words to describe, what does it mean to introduce reinforcement learning into language model such as...
Right. So essentially, the process of training these models contains multiple steps. The first step was called pre-training. You take a massive corpus of text, and then you train the model to get better at predicting the next token in this corpus of text. Anthropic literally bought and destroyed books in the process of destructive scanning in order to get better corpora for pre-training. And so originally, when GPT-3 was released in 2020, that was only pre-training. They were only training for the next token. But the problem with pre-trained models is that they are not very good at following instructions. And so like you ask it a question and then it responds with another question, because sometimes in the pre-training corpora you would find that there are just like lists of questions instead of question answer pairs or something like this, and then you'd have like an entire an entire kind of half magic, half science of prompting these models, of prepending the context such that this is a typical context in which a question is followed by an answer, so that these models can, like the capabilities of these models can be elicited. But this was not very useful for the broad public, and this was not the ChatGPT moment. And the ChatGPT moment was with the introduction of post-training. So post-training is a broad term of what happens after, well, pre-training. Now you also have mid-training, but that's like a whole separate story. And so now you have this base model, and then you want to make it more useful for, well, people who want to chat to it. And so for this, you introduce fine-tuning. So you say, okay, now I have some sort of supervised corpus of text where like questions are succeeded by answers, and then I will specifically fine-tune on that. And so that's one stage in the post-training pipeline. Then you have something that's called reinforcement learning from human feedback, or preference learning more broadly. So RLHF is one method to do post-training that doesn't require explicit written output. So for fine-tuning as a stage of post-training, you need to have people who actually write correct answers to your questions, and then you fine-tune on that. Then in the RLHF stage, which is confusingly very different from the RL thing that I was talking about earlier. So in the RLHF phase, what you do is you have humans label pairs of outputs. Which one is better than the other? And so this allows you to actually potentially get better than the human level, right? Because you only need to supervise. And it's easier to judge an output as good or bad than it is to produce an output on its own. And so the RLHF phase essentially trains the model to produce outputs that humans like without necessarily requiring humans explicitly writing the outputs. And then so in our understanding, I mean, we also don't know what happened in GPT-4, I think, or maybe like it's more figure outable now. But essentially, I don't think this is public information still. But in my understanding, GPT-4 was something like SFT, so supervised fine-tuning, plus RLHF for post-training. And then you have reinforcement learning. And so reinforcement learning, which is not reinforcement learning from human feedback, but rather what we call RLVR, so reinforcement learning with verifiable rewards, is something that allows you to get IMO-level mathematician LLMs. And so the way this works is you give it a problem, and this problem, let's say it's a mathematics problem, and this problem has a correct answer, let's say 42. Mm-hmm. Then you run the model, and so you have it think, right? So modern LLMs have like special thinking tokens that they can emit, and like they have like a thinking phase and then the output phase, right? So you have it think in this thinking phase, and then you have it produce the output, and in the output it should say, oh, and I also think the output is 42. And you have a reward model which says, okay, if 42 is found, then I will assign you like a reward of 1. If 42 is not found, then I will assign you a reward of 0. And so once you start doing this, then the kind of optimization pressure that you're putting on your models is very different. And in fact, we know that modern LLMs in their thinking process produce fairly alien outputs that no longer looks like human text. Because labs try very hard, they actually also fail, but they try very hard to not put direct optimization pressure on the chains of thought. So chain of thought is only an instrumental thing for the output that follows it. And so anything goes within the chain of thought as long as the correct output is produced. And one thing that is lost as a result is legibility. So you read the chains of thought and they look like kind of alien hyper-compressed text that's very difficult to interpret. And then we are kind of at the boundary of being able to interpret it currently. And so it's like the reinforcement learning, the fact that reinforcement learning can work for language model was a big surprise and a big update for many people in the field, I would say. Though I guess like people within OpenAI knew already that RL would be a thing and it's kind of ironic that RL makes a comeback, and in a sense very predictable, because before language models became a thing, the main path to general intelligence was envisioned by the big labs at the time, OpenAI and DeepMind, as reinforcement learning specifically. And so they weren't doing language, they were doing games, but they were doing reinforcement learning nevertheless. And so in a sense, it was expected that it would come back in some form once language models are introduced, but we didn't know how to do it.
So to kind of summarize, you said the initial stage of AI was just reproducing text, writing stories essentially. You get, the first chapter, write the ones that are coming. Then you kind of introduced feedback. You said, well, that's a bad story and it's a good story. It was helped improve it, so it was like human reinforcement in some way. Then this was kind of changed to say, well, then humans wrote the stories, and then one said whether it's a good story or a bad story, and then finally one just started giving AI different stories with solutions, and then asked it to kind of improve itself until it matches the solution. And I guess the last stage is what you said, is the reinforcement learning, and came in GPT-01, which allowed it to answer more precise problems from mathematics rather than just writing some sort of texts, which, philosophical texts, which are neither correct nor wrong, or can be interpreted, in any way.
Yeah.
Right?
More or less, this is correct. I would maybe clarify that the AIs were able to solve mathematical problems even before RL was introduced, because you can go some way by having humans who have some mathematical understanding of like giving thumbs up or thumbs down to an output. And this already produces an AI that can solve simple mathematical problems. But you can go much further by autonomously training on like large sets of problems where the only thing that you know is the correct answer.
Yeah. No, that's good. Then I guess building up on that, we can ask, I would rather want to ask you, why do you think the language approach to AI was so much more successful than any others?
Yeah. So there is an interesting intuition by the same Ilya Sutskever, who I mentioned earlier, for language specifically, where the objective that was chosen for pre-training, so predicting the next token, turned out to be extremely rich and scalable. So imagine you're reading a novel, a detective novel specifically, right? And you have hundreds and hundreds of pages of the detective going around, collecting clues, interrogating witnesses. And then at the very end, the novel ends as follows. The detective says, yes, I think I have it figured out now. The murderer is, and then so the next token follows, right? So in principle, in order for the language model to be able to answer what is the next token in this sequence, it has to amass an insane amount of context from the entire novel. And so, I mean, obviously this example is somewhat hyperbolic. These sorts of murderer is claims are not very frequent in the pre-training data, right? But at a smaller scale, this is constantly happening within the language models. So essentially, as you start training models at like becoming better and better at predicting the next tokens, when they want to squeeze out these last few, I don't know, hundreds part of a bit of entropy out of the loss, which is essentially the entropy of the distribution, right, that it produces, or like the cross entropy on the actual training corpus, it needs to pull out longer and longer context dependencies from text. So in the very beginning, GPT-2 could write semi-coherent paragraphs, and it was like a billion parameter model or something like this. And so syntactic structure merged first, right? So you know that he can be paired with is, but not with are, or something like this. And then you know these basic things about how sentences are constructed, where like commas should go, etc. But then, like, if you go like a step higher, then instead of just being correct syntactically, and like syntax is also very diverse, and like linguists were very hard at work at creating some sort of mechanical models that would kind of enumerate how English sentences can and cannot be constructed, but like I'm not sure if they were succeeding. I'm also not like a linguistic expert, but my understanding was that essentially, especially if you go into domains like colloquial speech, then it becomes much harder to like enumerate all the ways in which sentences can be constructed, right? And so this fell, and then you had the GPT-3, the model itself. It wasn't announced as by OpenAI as, oh, we released GPT-3, this big model. Like, it was announced as a paper, as a scientific paper, and the paper was called, I think, language models are few-shot learners. So what they realized is that an even bigger model that predicts text at an even finer granularity catches patterns which are much more long range, right? So one thing is style, for example. The way that this worked is you set up a paragraph of style, and maybe this is like, I don't know, writing in the style of Tolkien, and then it can produce Tolkien-like outputs afterwards. Because it captured these longer range dependencies, because they were helpful when predicting Tolkien tokens, right? You can say, okay, Tolkien would say the next thing as follows, but wouldn't say the next thing as follows. And so this is useful for dropping the loss slightly further. And so because of this, it can capture not only syntax, but style. But then it can also capture, through these kind of few-shot learning capabilities, right, that were announced in this paper, it can also capture patterns like the question in this prompt is followed by the correct answer. And this is also kind of a pattern in text. And sometimes it would encounter a bunch of text which had this pattern. Maybe this is like a solution list for, I don't know, a course or something like this. And this was sufficient. And this was like, it was useful for the model to predict that this specific question would be followed by a correct answer as opposed to a wrong answer. And this is also kind of a token level dependency in the text. And so this was useful to capture longer and longer text. And so essentially, you have a very simple loss. It's literally just cross entropy on the tokens. And this loss, in order to minimize it, kind of reveals this insanely complex structure, which is the structure of human knowledge, right? And so before that, you had approaches which tried to be more explicit. So there is this famous AI researcher from the classical, good old-fashioned AI era, called Douglas Lenat, if I remember his name correctly. I mean, he's still doing his own thing, which is this kind of logical approach in the language called Psych. And his idea at the time was that you just enumerate a bunch of facts in hyper-formal logical language about the world, and then you have a bunch of inference rules, and then they are kind of heuristical, right? And then you have AI that starts from these enumerated listed rules and then tries to, do inference on questions of relevance. And I mean, this kind of can be made to work, but it's much, much worse and it's much slower. And essentially, there is no simple connection where this like single loss captures this intrinsically complicated structure. And I think this is what made language models really work in the end.
I guess I was a bit lost in some parts, to be honest. But I guess the answer boils down to, well, text turned out to have quite a lot of patterns and dependencies that are present, that are very generalizable. And we found a very good way to process text using this loss function, which we haven't for many other mediums, or like video, for example.
Yeah, I guess to some extent this is true. I mean, for video, I think this is yet to come. Video is also a very good, rich medium, and video is being worked on. And I think one of the competing approaches to LLMs, for example, is the approach from Yan LeCun called JEPA, where, if I remember correctly, they do work with video. They try to predict these kind of temporal blocks of video, right? So you cut out a slice from the frame, but this slice is cut out across the entire frame, and then you hope to learn, for example, physics from this.
So you learn physics by observing physical reality in a video.
Well, you observe videos on YouTube, but hopefully they contain like significant enough amount of physical interactions,
I remember you learn the laws of physics. You kind of rediscover them from that.
In a sense, yeah.
That's quite interesting. I was not aware of that. Okay, so maybe another question. We're slowly moving towards the topic of your interest. We're not yet quite there. One more question. Well, I guess, everybody's talking about AI these days, and we have a lot of money being invested into AI research. You could say maybe if we invested so much money into, cancer research, we might have cured cancer. Who knows? Um, One of the things where AI was, successful in adding value, not just in terms of research, but in practice, is coding. So I think this is probably the area where I guess AI paid off in some sense. So, companies are paying for AI, coding agents, stuff like that. Why do you think that was, a lot more successful than I personally expected? Because I interpreted coding, and like, from a mathematical point of view, coding is more difficult than writing mathematical proofs. So I would not have expected AI to be better at coding than proving theorems. But for some reason it is.
Right. Well, I don't think that AI is better at coding than proving mathematical theorems in a relevant sense, actually. I think that the potential of AI to be successful at coding was much more elicited in the case of coding. So the potential of AI is not fully elicited in the case of mathematics, in my understanding, essentially, because AI for mathematics is more of a, I would say, kind of an advertisement thing for the labs, where they can say, oh, look, our language model is so smart, it manages to solve these IMO problems. And so they do put a bunch of money into that. But the real revenue is in coding, as you said. And so because of this, for them, it's much more important to have AIs which are good at coding. I do think that if they put as much effort into mathematics as they do in coding, then they probably would have had AI which is more successful in mathematics. I also think, obviously it's very hard to compare how to compare its performance in coding with its performance in mathematics. In coding, now AI is used in much more kind of interactive ways, right? Where you prompt the model, it writes a bunch of code. Then if this code is of relevance, then you probably check it yourself. And then you tell it, no, this is wrong, correct, this, right? With mathematics, mathematicians, I think, have some sort of a disdain for language models. And so they tend to not go through this process because they get the first output and it's wrong, and they like, no, whatever, I will abandon this entire direction. Like AIs are completely useless, right? I'm kind of simplifying here, but I think this kind of process is not happening, right? Where they could have gotten an output and were like, yeah, maybe something can be worked out of this, and like I'll prompt it further to like improve the proof, right? So yeah, we're not there yet with mathematics specifically. I mean, according to Terence Tao, we are getting there, and I guess according to Terence Tao, this is the future of mathematics, but who knows? Yeah, and so coding, like mathematics, turns out to be a problem where scalable learning can be applied with simple losses. And so because it has this quality, it has a quality of something we would in our field called being a crisp task. Namely, you can specify a reward function which will capture very well whether the model is performing well or not. Whereas, in contrast, something that we would call a fuzzy task is, research taste, right? Where there is no clear reward model for this experiment is good, this experiment is bad, right? And so because of this, it's much harder to make progress because you have to keep relying on input from humans. And it's kind of a $1 billion question, or you could even say $1 trillion question in the industry right now. How to work around this reliance on humans when providing feedback. So this is the problem of the scalable oversight, right? So coding doesn't have this problem. It's easy to do scalable oversight of coding.
Well, I guess they both have this problem. First of all, in mathematics, you could say there's a proof, and, if it's correct, it's correct. If it's not, it's not. And in coding, there's also a style, you have some guidelines on how to write good, scalable, error-free code.
Yeah, no, but I wasn't comparing coding and mathematics right now. I was comparing coding and research taste. I would say coding and mathematics are both crisp tasks. And then questions of research taste, higher level research planning, or poetry writing is a fuzzy task.
So you'd say mathematics would be the most affected one in research, but you don't yet know how quick the other areas of research will be affected by AI automation.
Well, if you count computer science, then in a certain sense, through coding, computer science is maybe affected more directly, more immediately. But yeah, I do expect that mathematics will be affected. I mean, biology is already being affected, even though this is very fuzzy, but like labs are putting a lot of effort into these automated researchers. I think when GPT-5 came out, one of the things that OpenAI did was pair up with like a biolab that was, or rather like a provider that was making these autonomous machines that would do biological experiments. You know, they can kind of do pipetting at scale. Um, and so you can also plug AIs there, you know, and then you combine them with other types of AIs that, for example, I don't know, predict protein structure like AlphaFold, etc., with this kind of open-ended ability to reason a little bit about bioresearch, and then you start this loop where AIs can do things autonomously, and then hopefully will discover the cure for cancer. And so in a sense, all these monies did go into curing cancer, but sort of indirectly.
Interesting. Well, you could make the same claim for anything, I guess.
Well, because it's general intelligence, right? So in a sense, yes.
Okay, speaking of general intelligence, what is AGI and why is it coming?
Right. Loaded question, right? Presumes the conclusion, but I mean, I do happen to agree that AGI is coming and that it's possible to define some forms of it. So AGI stands for Artificial General Intelligence. What is AGI is notoriously a difficult question. It's difficult to define. Many people talk about it in many different ways. I think since you're a logician, I will try to stick to like a more formal definition. So there is this researcher called Daniel Kokotailo, and he runs a non-profit organization called the AI Futures Project, and they specialize in making predictions, or what they call forecasts, about AI development. And as part of this, they want to have a forecast of the timelines to AGI, essentially, to artificial general intelligence. And they define it as what they call TED AI, so top expert dominating AI, meaning that in most domains where humans are experts, the AI can perform on par or better than experts most of the time. I'm not sure about the most of the time part, but I think this is roughly the definition. Maybe in general, AGI stands for this kind of holy grail of our field, right? So the model that is as good as humans at doing human tasks, right? And so the premise for why this is so consequential is that once it's there, it can, well, first of all, automate human labor, and second of all, it can do better versions of itself. And so then you start off these recursive self-improvement loops. The reason why it's coming is that if you think about it from the perspective of, well, what kind of tasks can AI do and how good it does it, then you start seeing that the AI is kind of eating up industries, right? It starts with certain kinds of areas of research, then it expands. Now we see, like, as we discussed, it's quickly advancing within mathematics. I mean, depending on your mathematical field, you can have more or less use for AI, but essentially, like, it's a kind of a question of scale, right? As long as, like, before OpenAI hires a logician, maybe they will not have like very good AI for, I don't know, computability theory, right? But then if they do find a computability theory specialist, then they can provide a few problems to the AI, and then slowly it will get better at that, right? With coding,
That would be hard.
it's
There's not
the
so
same
many.
thing. Well, I guess then your field is more safe. Go on, you know? But yeah, and so essentially it's kind of eating up various domains, and at the pace of improvement, you can expect that it would be eating up more and more domains, and then humans would have like fewer and fewer niches for themselves to occupy. And essentially, the question is whether or not it will encounter some sort of fundamental barriers to growth, right? Barriers to growth can be, for example, in fields which require real world interactions, like biology or robotics, famously. the reward loops, the feedback loops that the AI has are much slower. But even in those fields, progress is being made. And like NVIDIA, for example, very recently, if I remember correctly, set up the first lab to do kind of autonomous robotics research. And my understanding is that the labs are looking at robotics very closely, where the idea is that, well, maybe they can just buy up a bunch of robots and, well, have AIs train policies for them, and then it might just work. So advancements are being made in those fields. But then again, this argument that we just will kind of eat up all of the industries, it's actually unnecessarily strong. So I think you can proceed from just saying, yes, like we get better and better at all of sorts of domains of human expertise, and by default we should expect to just keep getting better there. But then there's actually like a weaker argument that you can make that it still leads us to AGI, and that is essentially from recursive self-improvement. The only thing that you really need in order for the AI to become, in a sense, general down the line might be that the AI is good at AI research. And so Anthropic very explicitly, for example, Anthropic is one of the leading AI labs, right? Like they release Claude, and they're very explicitly targeting the self-improvement capabilities of Claude. So it turns out that the labs themselves have a bunch of people who, well, know something about how AI is made, all right, and how to train AI. And so they themselves can become the training material for the AI, right? And they themselves can supervise whether the AI is doing a good job at doing AI research, for example. And once they do that, they can have an automated AI researcher. And so, for example, if I remember correctly, the AI Futures Project model, they specifically say that you first get an automated coder, then you get an automated AI researcher, and then you use the automated AI researcher to create AGI, or what they call top expert dominating AI. And from there on, you already have like a fairly brief window before what they would consider superintelligence. So yeah, essentially the idea for why AGI is coming is you create an AI that can do AI research, and then you do it, and then you have it do AI research in all other subdomains where you didn't have the time to do it.
But the fact that it self-improves itself doesn't mean that the improvement is indefinite. Maybe it's like there's only as much as you can improve, only as many bugs as you can find in a code, right? So let's say we have an AI which slightly rewrites its own code to speed it up and remove the bugs and increase the optimization and etc. etc. Wouldn't it plateau eventually?
Well, eventually, but where does it plateau? We don't know. And I think so far the trends point the opposite direction, right? You can say, oh, it can find only so many bugs, but bug finding is not the only area in which you want to be improving your AI. In some sense, Mythos, the model that found all these cybersecurity critical threats, that model is like a follow-up to GPT-2, And so in a sense, you can improve GPT-2 to make it into Mythos. How far you can improve Mythos to make it into something much stronger, right?
But how much, yeah, again, we're deflecting something, but just the last question on that topic, I guess. How much do these models really improve versus we just find new applications of them? So when I first heard about Mythos, I obviously didn't see it. I didn't see any papers, any break. Of course, I'm unaware, but I was not aware of any practical or theoretical breakthrough paper published in last year, which completely changed our understanding of language models, like the transformer paper that you mentioned before. How is it the model getting better versus they just found out, okay, if you apply it to this task in a smart way, it's good at solving it? In a sense, how much if we make a parallel, let's say you have a smart student and you just teach him cryptography. Now he's good at cryptography. He didn't really become smarter.
Well, you couldn't teach GPT-2 for sure these kinds of things, right? So, I think maybe underneath your question is like a very important concern for AI researchers, and that is, indeed, there was no breakthrough, like transformer level breakthrough since transformers. And there is a bunch of improvements to the transformer architecture that has been made. And there are some speculations that Mythos is not exactly the same kind of transformer as like earlier models. But it's still probably based on the transformer architecture. I don't have any private knowledge here, so I can speculate as well as you can, right? But the thing that changed them, and like one of the things that makes Mythos different from GPT-2 is the scale, right? So it's a much bigger model, and it turned out in AI that you have these kinds of scaling laws that tell you that, oh, if you make your AI bigger, then it predictably gets better at certain tasks. And in a certain sense, the Mythos success is downstream of this interesting phenomenon, and that's arguably a fundamental phenomenon about something like the nature of intelligence, actually. So it might be that you just don't need more breakthroughs; you just need to make them better or like bigger. Sorry, and then as you make them bigger, you need to find bugs. You need to slightly improve the architectures. You need to find more data. And we
So,
don't know how far this takes us. And so far, this process shows no signs of slowing.
so eventually, the kind of the hypothesis that drives this whole, AI money boom is, well, with the current research level at the AI, if we just scale them more and, refine the things that we are doing, we should get artificial general intelligence before we ran out of resources to scale the thing.
Yeah, that is indeed the hypothesis.
Interesting. Excuse me. So now, let me ask you a question that I know you're very passionate about. So, what are the dangers of AI as you see them? And you can give any sort of answer to this question.
Right. Well, yeah. By nature of my profession, I did have to think about this quite a lot. I would say the field generally lists these three broad categories. Apologies to any categories that I forgot. Of risks from AI. The first one is risk from rogue AI, and this one usually needs the most explanation. But this is the one that I'm working on. And so essentially, this is AI in a sense developing motivations of its own, and then realizing that these motivations are in conflict with ours, and then all of the bad things that happen downstream of that. Then there are misused risks. These are very understandable. If you make a tool that's very good at making bioweapons and then you give it to everyone, then sooner or later someone will make bioweapons. And then there are societal risks. So there is this notion that AI, as it gets better and displaces humans, will essentially also displace us broadly at the driver's seat of civilization. And so as the civilization develops, so far humans were in the loop at the key kind of points of development. So we are crucial for economics for the economy to run, because we are the consumers and producers of the goods for the economy, right? And the AI could change that. Or I don't know, we are the main producers and consumers of culture.
So imagine a world
society.
where AI is the producer and your value as human is measured by how much you can consume.
Yeah, I mean, we can get into this kind of branch of AI risks in more detail. That's something that the experts call the gradual disempowerment problem. I imagine a world where the AI is the producers and humans don't exist, because the AI is also the consumer, and that's the scary world. So we don't need humans to be consumers. AI agents can do procurement just fine. So that's kind of why we become detached from the process at both ends, actually. And so the same thing can happen with culture. And then you also have states, and this kind of morphs into the problems of concentration of power, right? So if one lab or one government suddenly develops artificial general intelligence, then almost by the premise they become much more powerful than any other actor in the field, and then they can essentially dictate their will to everyone, and that's also quite scary. But the societal risks require different expertise than the one that I have. So I can comment a little bit on why I think they are quite scary, but I don't think I have very good solutions for this. Incidentally, I also don't think the relevant experts have very good solutions to this. And the answers that we have so far is something like strengthen the democracy in relevant ways. But We don't really know, I think, what to do with things like gradual disempowerment. Yeah.
You said there's basically three, I guess, two and a half categories that you named. So the
Mhm.
AI, which becomes conscious in some way and starts having its own objective, whatever that means.
I would
Um,
object here that consciousness is really not a requirement. I think this is a fairly common misconception. Like maybe you just mentioned this for the convenience of the word, but I think it's very important to mention that consciousness and questions of AI welfare and whether AI is in a sense there and knows what's happening in some metaphysical sense is kind of irrelevant to any of the discussion of AI risk, or to most of it at least. Maybe a better term is situationally aware, so it understands what's happening around it. But consciousness has this kind of metaphysical baggage with it that I don't want to bring into the discussion, essentially.
okay. So then I guess risk number one is that it becomes situationally aware
Mm-hmm.
and decides to do things that we don't want it to do, which again, somehow this decision is a judgment called of AI based on situational awareness.
Mm-hmm.
The second one is that malicious actors can use AI to do malicious things,
Mm-hmm.
and I guess the third one, which goes, well, maybe it's a different category, is that or a bad scenario in the scenario one is that humans are essentially out of the loop and the AI just runs things now. Whether this happened by situation one where AI got misaligned, or just somebody constructed an AI with this goal, and now a malicious actor, now AI just runs things because it's better at running them, and eventually we're not in charge. Is there
Yeah.
any other major category that we missed, or which is important to name?
I think I would focus on these three. It's plausible that I'm missing something, but at least these are the ones that I'm most familiar with.
How about that the AI is making us stupid?
I would say that this is in the category of the societal risks. That's the last
Hmm.
one. You named it in the sense of AI specifically put us out of the loop, and I mean that's also kind of the way that I frame this, but you can see it more broadly. I think AI is making us stupid is a facet of gradual disempowerment, essentially.
Hmm. No, but in a sense that, let's say, it doesn't disempower us, just that people who use AI more, use their brain less, and the people who, this is a common, let's say,
Right.
thesis across
Mm-hmm.
many branches of society. Well, if you use AI, kind of become stupid. You can't read things anymore. You can't write things anymore. And then
Mm-hmm.
the only way to kind of, remain relevant is to try to think for yourself and not use the AI, independently of whether, AI
Right.
becomes.
Well, I think you can take this scenario and split it into two sub scenarios.
Mhm,
So in the first sub scenario, AGI is never developed and AI becomes remains kind of a useless tool. This is
mhm,
actually the good scenario
mhm,
because in that sense, what happens is there are some people who correctly call out the fact that AI is stupid and then don't use it, right? And then they remain relevant and
mhm,
essentially competence of humanity and humanity being in the driver's seat as a property is preserved.
mhm,
And then there's another sub scenario where AI does become good. And so the scary part about gradual disempowerment is that every individual actor has an incentive to deploy AI, to offload their thinking. And so in the case that AI can do breakthrough mathematical research, and in case it can do so much better than humans, for example, right?
mhm,
Then the mathematicians have the incentive to offload their thinking to AI. And some might not, and some might. And those who
mhm,
might, they will start winning, I don't know, the Abel prizes or whatever, right?
mhm,
And then the other ones are left in the dust. And so then gradual disempowerment happened, and it happened in a bad way. Where, yes, indeed, those other ones who offloaded their thinking maybe became dumber, but they are nevertheless more productive because the AI is doing the thinking for them. And then you see the scary gradual disempowerment happening.
So I guess you say it's a betting game. So the one bet is, well, AI is going to become better and better, so one should learn to use it and offload things as much as possible if one in the branch one wants to be successful in, because this is the way to success. Or AI will eventually plateau, and then instead of learning things, you offloaded many things that you should have learned, and then you eventually plateau together with AI because you didn't learn the things you should have. And then depending on which of these two scenarios comes, you're in the losers or in the winners team.
Yeah, I think this is accurate.
I see. So maybe to spice it up a little, there is a term, a buzzword now on the internet with respect to AI societal risks, I guess. So category 3, which is the permanent underclass. Can you comment on that?
Yeah. Well, the lead researcher behind the gradual disempowerment paper actually commented on the permanent underclass meme. But I guess before I give commentary, maybe it's worth explaining what the meme is essentially about, right? The permanent underclass idea is the notion that essentially AI will drive vast inequality. And yes, indeed, I think this is in the societal risks category, where people who either use AI or more, I mean, depending on who makes the claim and who wants to sell you what, they will tell you that permanent underclass constitutes different classes of people, right? But I think the kind of more standard notion is essentially that people in the labs, people who are developing the AIs, are also people who will get the benefits of it, right? So notoriously, if OpenAI serves ChatGPT in Europe, then I think due to some recent agreements about how taxing works, it's not clear that Europe can kind of tax the usage of OpenAI there, right? And if this kind of scenario happens, then essentially what happens is the human workers in Europe are automated. They are the permanent underclass because they don't have anything to show up for this, right? And instead, the profits that would before that it would be their salaries, they go into the pocket of OpenAI, they go into the pocket of the US government because they are taxing OpenAI, right? And correspondingly, whether you have access to AI or not determines whether you have a kind of an economically viable future. And otherwise you are in what is called a permanent underclass, right? And then there's the related notion, which I think is kind of not a very good prediction, but essentially, do I think that which I think is kind of slightly less relevant, would be the correct way to say this. And that is that, if you don't use AI enough, then you're immediately falling behind, which it's also true. But in the end, that might not be the decisive factor of your membership in the permanent underclass. So that is the notion of permanent underclass. And then it is a very scary idea, and it's a very mimetically powerful idea, you can say, because it captures the minds with fear, right? Oh no, I don't have access to AI, I'm not using AI enough, right? I'm not working in the lab, therefore I will not be able to capture the slice of the future, right? And so because this is so scary and so simple to express in a sense, it becomes very stable in the discourse. But I don't think that's a very good notion to some degree, because if the AGI is developed, then I believe it's quite likely that from AGI we get to ASI, so artificial superintelligence, fairly quickly. And then essentially the problem with the notion of permanent underclass is that the things get so weird that our standard ontology, our standard way of modeling things as, these people are rich, these people are poor, no longer apply. If those people who had access to AI are rich or something like this, then it's either we enter some sort of state, I think that the distribution of outcomes is fairly bimodal. Either we enter some sort of state of abundance where maybe there are some people who own, I don't know, much more resources, but essentially the others live amazing lives. And because we have this state of abundance, there is kind of enough stuff for everyone, right? Or we literally all die out from AI because the first category of risks materialized and you have these kind of rogue AI things. Or you could be in some sort of dystopia, right? Where maybe there's, 5 people at the top or something like this who run this thing in an Orwellian manner. But then I think money becomes less relevant as a point of leverage, especially as the economy detaches more and more from humans. Money becomes less and less kind of a central point for them, or money in the traditional sense. And you being rich, like essentially, let's say I avoid the permanent underclass because I'm very rich, or I don't know, I work at an AI lab, right? But then if the economy develops at an exponential rate and then I don't do my investments perfectly well because I don't know, even though I'm within the AI lab, it may be that I'm kind of politically outmaneuvered or something like this, right? Then it's very easy to have all of your assets become irrelevant in the grand scheme of things because the economy just ran away so far. And so in the case where you have this kind of, I don't know, oligarchy class, then it might just be so small and concentrated that like everyone's in the permanent underclass for all practical reasons, essentially.
So basically your conclusion is, well, if it turns out good with the AGI and SGI, there will be no permanent underclass because money becomes redundant. And if it turns out bad, everyone will gonna be in there. So one shouldn't worry about it because one cannot control it.
Yes, I would say this is accurate.
Well, I guess this is reassuring for some, hopefully. Yeah, then let's move to the last question. Might be your favorite. Here you can let your mind wander and, tell things that might turn out wrong. So what should we expect in the future, according to you, with a timeline?
I think I am not the best person to ask this because I don't do AI forecast professionally. And so when I think about the future, I tend to defer to professional forecasters. And I think the best forecasters of AI that exist out there are these group called the AI Futures Project. And they have a very specific timeline, which they update fairly frequently. They operate more like traders in the sense of, and in at the moment that new information arrives, they update their forecast. But that sometimes discredits them with the traditional media because maybe they get better alpha now, right? And so they change their forecast. But then the media can come to them and say, oh, but 2 months ago you said that it was AI 2027, right? And now you say it's AI 2030. But I think this is the way that forecasts should work, essentially. And so this is the way that they work for them. And so the original model that they published, and I think that made a lot of media noise, was the AI 2027 model, which essentially posited something like the artificial general intelligence gets developed in 2027. And I think after a year passed, this is still the view of some researchers, notably at Anthropic. People have very short timelines of a couple of years, meaning that they expect that their work is done in 2 years or so, right? And so they create this AI that can do AI research better than themselves, and then they just sit back and then press play, and then the scary things happen, right? But the AI futures model is now slightly slower than the median researchers at Anthropic, in my understanding, and they predict that this kind of general intelligence comes around 2030. I tend to do something like put a managerial multiplier on these things. So I know that this is very ungrounded, and probably the people at the AI Futures Project, they kind of already account for this, right? They look at the trends of development and maybe they have certain confidence intervals, etc., right? But you can apply the heuristic. Things always take slightly longer than you expect them to, or even not slightly. And what I tend to do is I tend to take these kinds of forecasts and multiply them 2-3x, and then you get from now on, what is today? Today's 2026, right? So if AI is developed in 2030, that's in 4 years. So you get something like 2034, right? I expect general intelligence somewhere in the 2030s. Now, there is a better argument to be made to have timelines which are slightly slower than the timelines put out by the AI Futures Project. And that is, they expect, so essentially, there are certain quantifiable metrics of AI development Famously, there is this time horizon measure where researchers take certain type tasks specifically for software developers, right? So we know that AI is particularly good at software development.
Mm-hmm.
And so they take specific tasks that take software developers a certain amount of time, and then they measure like how likely is it that the AI will perform these tasks successfully. And so
Mm-hmm.
you can introduce a measure that's called, for example, a 50% or an 80% uh, task completion time horizon. So you can measure on average what is the length of a task that the AI can complete with an 80% accuracy. And so that thing has been growing exponentially over the past actually several years fairly reliably.
Mm-hmm.
Um, and then you can say, once this reaches something like a year, then you are in a meaningful sense in the AGI scenario. Or like rather, you see, because AGI is such a poorly defined term, you are in a scenario of automated coder. And so
Mm-hmm.
that's essentially like a stage in the development where suddenly you don't need to write code anymore. And then you apply this coder to, well, develop better AI. And then there's a question of like diffusion, and the coder can also help you diffuse itself, right, throughout the economy, meaning that like it can like find better, like find easier ways of integration, etc. Right. So you get the automated coder at some point. And so far the line has been straight, right? So meaning like if you plot the y-axis on the logarithmic scale, then you see like a straight line development of like the time horizon of the AI versus time, right?
Mm-hmm.
And the AI Futures project expect this line to bend upward. So they expect super exponential development
Mm-hmm.
because AI will be more and more useful for coding itself, right? But I think a good counter argument is something like, well, we should already expect to see this happening. Anthropic employees claim to be amplified by something like 2x by current AI models. And the Anthropic senior management thinks that the figure is more like 1.5, if I remember correctly from their blog posts. Um, so you should already expect that the line will start to bend from now on. And Mythos could be an indicator that it is bending. But if the line doesn't bend, and if we keep the exponential pace of development, then you should expect the automated coder by around 2030, mid 2030s. And if it does bend, then you expect it in early 2030s, essentially. I am in the camp of it not bending that much, but we'll see who's right in the next year or two already.
I see. So essentially, to again summarize this, we have about, according to you, about 10 years till the automated coda, maybe then a few years more till the AGI, after it's developed, trickles down to all other areas of a society. So, you people listening have about 12 years to get your life together, because after
Yeah.
that, who knows what's coming. Yeah,
Yeah,
well,
that's a pretty destabilizing thing to learn, I guess. It does indeed change one's outlook quite a bit if you think about it in this terms. But yeah, I do think that things are going to get crazy within our lifetimes, and even quite soon within our lifetimes. Arguably, things are already getting crazy.
that is true. That is true. Okay. Well, that was a insightful conversation. I enjoyed it, and I hope you did too, as well as the others.
No, it was quite interesting to discuss all of those things. Bit of a shame that we didn't go as much into the risks from rogue AI in particular, which was my area of expertise, but
Well,
maybe some
you
other
know,
time.
exactly. That we still have 12 years, and
Right.
there will be more
To discuss
episodes,
them in more
and
detail. Yeah.
I would be happy, one day to do a more detailed one. But I think, before one goes into detail, it's good to have some sort of, also for me, since I'm not an expert on this topic, to have sort of a rough idea of what's going on, and then go more in depth in one specific thing, which is more close to your heart. I guess if I would start it to, just tell you a random result from computability theory without the backstory, you would probably ask, why should we care? And this would be a rightful question.
That's
Um,
fair.
so I guess you explained to us why to us today why we should care, and I care now, which is good.
That's great to hear. That's great to hear. I hope your listeners get to care too.
Yeah, yeah. Well, 12 years. That's the time to reach enlightenment.
Mhm.
And yes, as said, I'll be happy to come back to this topic sometime in the future. Any final words you'd like to say, and something you forgot you wanted to mention but didn't have the opportunity to?
I mean, I mentioned the broad categories of risks, I guess. Um, I
Some
would
advice,
like to
maybe?
say
I don't know.
advice for people. Well,
Get a
for
clause
people
subscription.
already closer to AI, um, I think you should be doing AI safety essentially. The field is in a dire need of researchers. If you're
As
doing
this
policy
goes through.
adjacent work or could see yourself going into policy adjacent work, then I would urge you even stronger to go into policy for AI, because this field is has an even bigger problem of cadres, because people who typically do AI researchers are not people who are also very much into policy. But this is the kind of people that we need much more. Um, and yeah, like it's worth to stay aware, but it's also worth to touch grass. This advice goes more for people who track the field more densely, as I myself do, and many others who are close to my line of work do. For them, it's worth doing the opposite thing, and to go out and like actually experience life outside of the AI bubble.
So what should an average Joe do? You said what should that the powerful people do,
Well,
but
the average Joe should probably use Claude Code quite a bit more than they currently do, and should at least become aware of what these tools are capable of, because this might bring a lot of confusion, and that might also be a rather destabilizing experience. But it's also worthwhile staying situationally aware ourselves.
that does indeed sound worthy doing. Okay. Then I guess I would like to thank you for your time and our listeners too. It was a big pleasure. I learned a lot, and see everybody else in the next episode. Goodbye.